All right, so we're going to be working on Chapter 6, Lesson 2, Solving Inequalities by Multiplication and Division. So the learning targets for today are going to be solving linear inequalities by using multiplication and solving inequalities by using division. So why are inequalities important in landscaping? So it says, Isabella Franco is a landscape architect. To beautify a garden, she plans to build a decorative wall of either bricks or blocks. Each brick is 3 inches high and each block is 12 inches high. Notice that 3 is less than 12. So here are the bricks, here are the blocks. So if a wall 4 bricks high would be lower than a wall 4 blocks high. So here's 4 bricks high, here's 4 blocks high. Each brick is 3 inches, each block is 12 inches. So clearly something that's 4 blocks high here and 8 blocks high, or 4 blocks high here. So four bricks, 4 blocks. So if one is 3 inches and one is 12 inches, clearly we know that 3 is less than 12, right? Well, if these 3-inch bricks, and there's 4 of them, and then we have these 12-inch blocks, and there's 4 of them, well, if we multiplied both of them by 4, right, 3 times 4, that would give me 12. And 12 times 4 would give me 48. Well, the 12 inches of this wall is still less than the 48 inches of this wall, whether we count them in how much each block or brick is worth or the total size of the wall. So this is just showing you that if we multiplied both sides by the same number, the left side is still smaller than the right side. So this leads us into our discussion today about how do you solve inequalities by multiplication. In each side of an inequality, it is multiplied by a positive number. The inequality remains true. So here's an example. Here I have 8 is greater than 5. That's an easy one for us to identify, right? Well, what if I were to multiply both sides by 2, right? 8 times 2 is 16. 5 times 2 is 10. Well, I know that 16 is still greater than 10. So if you noticed, when I multiplied both sides by the same thing, the left side is still greater than the right side, just like before, right? The inequality stays true. Here we see that 5 is less than 9. Well, what if we multiplied both sides by 4? 5 times 4 is 20, 9 times 4 is 36, and the left side is still less than the right side. The inequality stayed the same as long as I multiplied both sides by the same number. Now, this is only true if we're multiplying both sides by a positive number. Well, if we multiply both sides by a negative number, it works a little differently. So let's look at 5 is greater than 3. Well, what happens if we multiply both sides by negative 2? 5 times negative 2 is negative 10, and 3 times negative 2 is negative 6. Well, negative 10 is actually less than negative 6. And if you notice what happened to the inequality symbol, it flipped the other direction. So here, when we multiplied both sides by the same number, it was negative, and it ended up flipping the inequality symbol. Let's look at one more example. Here we know that negative 6 is less than 8. Well, what happens if we multiply both sides by negative 5? If we're multiplying both sides by a negative number, right, negative 6 times negative 5 is positive 30, and positive 8 times negative 5 is negative 40. Well, now we can see that negative 40 is actually less than 30, right? Or 30 is greater than negative 40. And if you notice, the inequality symbol flips. So if we multiply both sides by a negative number, the inequality symbol flips. If we multiply both sides by a positive number, the inequality symbol stays the same. So remember, when you're solving, if you're multiplying both sides by a positive, inequality symbol stays the same. If you're multiplying both sides by a negative, inequality symbol flips. So in each side of the inequality is multiplied by a negative number, the direction of the inequality symbol changes. These examples illustrate what is known as the multiplication property of inequalities. So here, if you multiply by a positive number, right? If you multiply by a positive number, the inequality symbol stays the same. And if you multiply by a negative number, the inequality symbol flips, right? So that's what all this stuff is saying, just what it illustrated in the previous examples there. So let's look and see what this looks like in an example. So let's solve b over 7 is greater than or equal to 25. So this is just like b divided by 7. So when we're solving an inequality, just like an equation, we're trying to isolate the variable, get the variable by itself. So that's b divided by 7. So the opposite of dividing by 7 is multiply by 7. So I'm going to go ahead and multiply both sides by 7. Right? These 7s will cancel out, leaves you with just the b. And then I'm going to do 7 times 25. Now, I am multiplying both sides by a positive number, so the inequality symbol will stay the same. So I'll get b is greater than or equal to 175. So let's go ahead and check the solution just to make sure that it works. So let's start by, it says that it can equal 175. Let's go ahead and use 175. So if I do 175 for b, right, so 175 divided by 7, that's going to be 25. Is 25 greater than or equal to 25? Well, it's definitely equal to, so it checks out. Let's try a number that's less than 175. Let's try a number like 140. So 140 divided by 7 is 20. So 20 is not greater than or equal to 25, so clearly that didn't work. Let's try a number that's bigger or greater than 175, like 210. 210 divided by 7 is 30. Is 30 greater than or equal to 25? It is. It checks out. So numbers greater than 175 and equal to 175 both worked, and anything that was less than 175 did not work. So our solution for b is that b must be greater than or equal to 175. Let's see what happens if we have something with a negative number. So if you notice, I have negative 2/5 p is less than or equal to 4, or less than 14, not equal to. There's no line underneath. So let's take the original inequality. If I needed to get the variable by itself, I need to cancel out this fraction. So remember, how do you cancel out fractions? By multiplying by its reciprocal. What is the reciprocal of 2/5? That would be 5/2. Take the fraction and flip it upside down. So not only do I want to multiply by 5/2, I want to multiply by negative 5/2 because I want to get rid of that negative as well. So I'm going to multiply both sides by negative 5/2, right? The 5's cancel, the 2's cancel, a negative times a negative is a positive. And since I'm multiplying both sides by a negative, right? What I did was multiply both sides by a negative. I need to remember that the inequality symbol flips directions. So that's going to tell me that p is now greater than, when I multiply these together, that's going to give me 35. So p must be greater than positive 35. So this is one of those times you have to remember, if you multiply both sides by a negative, you need to flip the inequality symbol. So it used to be less than, now it's greater than. So one thing that you want to remember is, if you had an example like this one where x over 6 is greater than negative 3, we'd be multiplying both sides by positive 6, correct? Don't ever get confused that just because there's a negative, you have to flip the inequality. You're always looking at what you multiply both sides by. If you multiply both sides by a negative, it flips. If you multiply both sides by a positive, it stays the same. So in this scenario, some people might say like, ooh, I'm going to flip it because there's a negative, but that's not true. In this scenario, to solve this inequality, we'd want to multiply both sides by positive 6, which would mean the inequality symbol stays the same. Okay, so just make sure you keep that in mind. Look at what you did to both sides to know if you should keep the symbol the same or flip it. Let's look at number 3. So it says write an inequality for the sentence below, then solve it. It says 1/4 of a number is less than negative 7. So 1/4 of a number is less than negative 7. So 1/4 of a number, so 1/4 times a number, n, is less than negative 7. So my inequality would look something like this. 1/4 times n is less than negative 7. So again, I'm solving for n, right? I'm solving for n. So I need to get rid of this fraction. I can get rid of this fraction by multiplying by its reciprocal, 4/1, or 4. So I multiply both sides by 4, right? This 4 times 1/4 will cancel out. That'll just be like 1n. And then 4 times -7 is -28. Now notice the inequality symbol stayed the same because what I multiplied both sides by was +4. When I multiply both sides by a positive, it stays the same. Some people, this is what I was talking about in the previous slide, is some people think like, oh, there's a negative, I gotta flip it. No, because we didn't multiply both sides by a negative, we multiplied both sides by a positive. So it stayed the same, the inequality symbol. So our answer would be that n must be less than -28. So solving inequalities by division is the same as multiplying. Okay, so if you divide both sides by the same number, the inequality symbol should stay the same, right? So if I do 6 is less than 15, well, what happens if I divide both sides by 3? That's going to be 2 is less than 5, right? Inequality symbol stayed the same because I divided both sides by a positive, right? Well, let's look if I divide by negatives. Same scenario, 6 is less than 15. What happens if I divide both sides by -3? 6 divided by -3 is -2, and 15 divided by -3 is -5. So -2 is actually greater than -5, right? This negative number is actually smaller than this negative number, right? So the inequality symbol did flip. So if you divide both sides by a positive, the inequality symbol stays the same. If you divide both sides by a negative, the inequality symbol flips directions. This is what's known as the division property of inequalities. These are just the core concepts. Basically, divide both sides by a positive number, inequality symbol stays the same. Divide both sides by a negative number, inequality symbol flips. Let's look at an example. What happens if we divide by a positive number? So here I have 14h is greater than 91. So again, I'm going to solve for h. So I got to get rid of the 14. That's like 14 times h. Opposite of multiplying is dividing. So if I divide both sides by 14, it's going to give me that h is greater than 6.5. I divided both sides by a positive number, which is why the inequality symbol stayed the same, right? Stayed in the same direction. Let's go ahead and give a quick check. If I check 6.5, right, equal to 6.5, and I put the number in, 14 times 6.5 is 91. Does 91 greater than 91? No, because look, there's no line underneath. It can't be equal. What if we pick 7, right? 7 is greater than 6.5. So 14 times 7, that's going to give me 98. Is 98 greater than 91? Yep, that one checks out. Let's pick a number smaller than 6.5. Let's pick 6. 14 times 6 is going to give me 84. 84 is not greater than 91, so that did not check out. So clearly h has to be all the numbers that are greater than 6.5. They can't be equal to 6.5, right? That didn't work out. And they can't be less than 6.5. So that would be the solution set. H has to be greater than 6.5. Look at another one. What happens if you divide by a negative number? Well, I have -5t is greater than or equal to 275. Well, if I'm solving this, I would go ahead again. I'm solving for t, so I got to get rid of this -5 here. That's like -5 times t. The opposite of multiplying by -5 is dividing by -5. So if I divide both sides by -5, I'm dividing both sides by a negative. The inequality symbol has to switch directions. So when I solve that, I get t is less than or equal to -55, right? Whenever you divide or multiply both sides by a negative, the inequality symbol flips directions. So that would be my final answer there. All right, thank you guys for watching. Let me know if you guys have any questions.